Hey class, this is 6.3. This is division properties of exponents. Very similar to yesterday. We're going to add 2 rules today, and I believe we're leaving off on rule number 6. So you should have 1 and 2 from 6.1, 2, 3, and 4. No, I'm sorry, 3, 4, and 5 from 6.2, and we should be starting with rule number 6 today. So the first thing we're going to talk about is the quotient of powers property. So what's that talking about? You can look up there and you can see, but I'm going to restate the rule. I want to write it here. So same thing I love about this chapter. You can figure all these out on your own. So if I give you an example of something like 5 to the 7th over 5 squared. Now you don't have to do this every single time, but it helps if you get on the test and you can't remember what's going on. It helps to write this out. We know that the top wants us to do that 7 times, so 5 times 5 times 5 times 5 times 5. There's 7 of them. And on the bottom it wants us to do it twice, so we've got 5 times 5. Now, we know what's going to happen. When I have a 5 over 5, it cancels out, so I can cancel this one right here with that one, and I can cancel that one with that one, which means we have 5 5s left over, and we can write that as 5 to the 5th. So, the other way I could do it, here's another example. I could do x squared over x to the 3rd. We know that this means x times x. We know that this means x times x times x. So we're going to have these two cancel. We're going to have one x left over, and it's going to be on the bottom. So take a look at this for a second, and you can probably figure out what the rule is, what's happening every single time when you have the same base on the top and the same base on the bottom. You'll notice what you're doing is you're subtracting. So if you do 7 minus 2, you get the 5. And if you do 3 minus 2, you get an imaginary 1 that's right here. So the rule is, when you have the same base on the top and the same base on the bottom, you're going to subtract. So this is how I want you to put it in your notes. This will be rule number 6, and this will be quotient of powers. So quotient of powers. If same base is raised to an exponent, I'm going to say subtract the exponents and leave the extras where there are more. This needs to go in your notes, so you should be writing this right along with me. And what do I mean by that? Now, you could just always subtract. So if you notice right here, we could take 2 minus 3 and we could get negative 1. That would give us x to the negative 1, right? Sorry about that. But is the negative 1 happy? The negative 1's not happy, so then we would end up having to ship it to the basement, and we'd end up right over here. So instead of subtracting and then having to ship it to the top or ship it to the basement, if you just always subtract and you leave the extras where there are more, you'll be all set. So here we had more on top, so 7 minus 2 gives me 5, so I leave the 5s up top here. Down here the extras are on the bottom, so when I do 3 minus 2, I leave the 1 on the bottom. And you can put these examples in your notes. If you want to put examples underneath the rules, put those 2 examples right there. So next slide, let's try a couple examples. So you don't have to write this all out because now we know the rule. So if I just do 7 minus 2, that gives me 2 to the 5th. And if I were you, I would pause this, I would try these examples, and then you can go back and take a look, see if you got it right. We do 4 minus 3 here, and we get x to the 1. Some of these we have to clean things up first. So you learned this yesterday. That 2 has got to go there, and that 2 has got to go there. So this makes it d to the 4, e to the 3, over d to the 2, e to the 2. Now since these are the same base right here, I can just subtract. And so I have 4 minus 2, I have 2 d's on top, because that's where the extras are. 3 minus 2 is 1, and the extras are on top, so I have e to the 1. And you can put that 1 or not put that 1, it doesn't really matter. Down here, you can put an imaginary 1 there if you want. So I take those and I subtract, and I have 1 on the bottom. Take those and subtract, and I have 1 on the bottom. Take these and subtract, and I have 2 on the top. Now be very careful here. Don't just mush those together and make it look like a 34. These are 2 separate things. So it would probably be a good idea for us on this one to call this 5 squared over 12 so that we don't get that confused. Okay? Here's some more examples. Those are pretty much the same thing, so I'm going to skip those. Here's our next problem. And again, you can write this out. This says a quotient to a positive power. So what's that talking about? Well, a quotient, you can see right here, 3 to the over 5. That is a quotient because it's division to the power of 4. Well, if we write that out 4 times, 3 to the 5th times 3 to the 5th times 3 to the 5th, times 3 to the 5th, and mush that all together, we get 3 3's on top and 5 4's on the bottom. So we've got 3 to the 4th over 5 to the 4th. I'll do an example with x's and y's. So if I have x over y, and I'm actually going to do x squared over y cubed to the 2nd. Now if I write that, x squared over y cubed times x squared over y cubed, and then I could even expand this out more. I could do x times x times x times x over y times y times y times y times y times y. Or I can use the rule I learned yesterday, and I can do x to the 4th over y to the 6th. So, what is the rule that we have going on here? The rule is very similar to yesterday's rule when you had a product to a power. This is just a quotient to a power. So this is going to be rule number 7. So a quotient to a power. And I am going to say, just like yesterday, distribute the exponent to everything. Remember yesterday, it's very important even to go to the numbers. So if I give you a quick example here, if I give you like 2 over x to the 7th, remember that has to go here and it has to go here. So you're going to get 2 to the 7th over x to the 7th. So let's do a couple examples of that. You can put that in your notes with the example. So if I do this one here, this is going to give me 4 squared over 7 squared. My advice to you, same as yesterday, I would split these up first, and if it helps you, I'd put a little 1 right there. Split this up, put a 1, put a 1. So this has got to go to all of those. So this is 3 to the 4th, d to the 8th, e to the 4th, f to the 4th. I'm not going to do all of these because I think you can get the hang of it. This is going to be 2 to the 6th, 3 to the 4th. You do not have to expand it out. You can leave it like that. You're going to do this right here. One more piece of advice. Make sure you simplify everything first. Well, 2 pieces of advice. Number 1, make sure you work inside out. So if we look at this one, we're going to start on the very inside first. And this is going to be x cubed, y cubed. Okay, that's piece of advice number 1, work inside out. Piece of advice number 2 is simplify first, because if I simplify everything on the inside here, this x cubed over x cubed cancel each other out. So now all I have to do is go here and go here. So this is 2 squared over y to the 6th. So same thing down here, make sure you simplify first. I can cancel out 2 of these a's. So this disappears, and I'm left with a 1. This disappears right here, and I'm left with a 1, because remember I subtract those. So now when I go there, I get A3 over B3. Okay? Last rule, this will be the last rule on your Chapter 6 rules. This is a quotient to a negative power. This is really, you could get away with not having this rule at all. It's kind of a bonus, and I'll show you quick. So if I have something like this, 2/3 to the negative 4, you could do exactly what I just told you. You could do this, and you could do that, and you would get 2 to the negative 4 over 3 to the negative 4. But then we have to make sure it's happy. So that's not happy. I'm going to shift that to the basement and make it positive. That's not happy. I'm going to shift that up top and make it positive. So you could do that, which is completely fine. Or, if you want to make your life easier, here's the rule. So the rule says, this is number 7, 8. What are we on? This is number 8. So the rule says, so quotient to a negative power. It says to flip the quotient over and make the power positive. First. You'll get the exact same answer, but if you look at this up here, we go back to this one. So what I would do first is I would start by flipping that over. So I'd make it 3 over 2, and then I would make that a positive 4. And then if I do this, I'm going to get 3 to the 4th over 2 to the 4th, which would be the exact same thing that I got right there. So you can do the same thing and you get to the same spot. You move on, I'll do a couple examples for you. So, let me do this one. It's kind of ugly. So if I follow their rule, I'm going to flip this over first. So I'm going to get 3 over 2, and I'm going to change it to a positive. If I follow my advice that I gave you on the last slide, the first thing I'm going to do is to reduce. So if I reduce this 6 over 2, that disappears and this becomes a plain old 3. I'm going to flip this over. I'm going to have n over 3m to the positive 3. And now I'm going to follow the last rule number 7, and I'm going to do this right here. So I'm going to have 3 squared over 2 squared. And I'm going to have this going on, so I'm going to have n cubed over 3 cubed over m. And then I can mush all that stuff back together. So if I mush it all back together, this just becomes one giant thing all stuck together. And I can do a little bit of simplifying, because I have 2 3's on top, which are going to cancel with these down here, and I'll just be left with 1. So I would have n cubed over 2 squared times 3 times m cubed. And I really should probably squeeze those together too. So 4 times 3 would just be 12. So n cubed over 12 n cubed. Okay? I will do one more. Let's see, are there any more exciting? You know what, I'm going to skip it because I'm running out of time. So just a couple more things. Take a look at this, pause this, read those rules. You're not done simplifying if any of these still exist. You can't have any negatives. You can't have any of this stuff seen down here in these examples. Basically, it just means follow all the rules that I've given you. And then the last slide here, I want to do one division of scientific notation. So if I have scientific notation, I have something, you know what, I'm going to skip that. I will show you that on Tuesday. So hopefully Alright guys, so hopefully that's enough examples to get started. Again, like always, it's very easy to go through these fast and scribble stuff down, so check with the people around you, ask questions, compare answers, and I'll see you guys tomorrow.